The second topic in this lesson is disaster recovery. So we are going to look at how we can get business continuity in the event of a natural disaster, or maybe a cyber attack or something else, terminating an entire Azure region where our Azure SQL database happens to be hosted. So the first note here talk about standard geo-replication. Now with this, it asynchronously replicates committed transactions from an online primary to an offline secondary in a predefined Azure region. The standard geo-replication is designed for environments where the only purpose of having this replica is to implement DR, disaster recovery or DR, and it's not to offload the readable secondaries. Now, with standard geo-replication, only one secondary is allowed in a DR paired region. Each region has a DR pair that can only host a secondary database. The secondary database is offline. This is the big difference with standard and active. It's offline and unreadable. Okay. The secondary database is readable when a failover happens. The secondary database you get at discounted rates as it's unreadable. Now, the secondary replica is supported across all service tiers too. Now, we can get a list of our disaster recovery paired regions on this Microsoft blog. And it just lists up which are the DR pairs for each region. They're usually within close proximity to each other, but not that close. Now, the key thing here is failover. If an Azure region fails, you will get an alert on the portal about the region failure. The state of the Azure SQL Server on that region is set to degraded, and then from here you've got a couple of options. So much like an on-premises DR situation, you've got a choice to make when the disaster happens. You can immediately perform a manual failover to a secondary database, or you always have the option of waiting for the region to recover. If you immediately perform a manual failover to the secondary database, the geo-replication has a recovery point objective of less than 5 seconds. Now, RPO is the maximum duration in which data might be lost from an outage. Therefore, if your application can survive a data loss of less than 5 seconds, or you have a way of managing the data loss in the application code, then you're advised to fail over to the secondary. Once the failover has completed, you will have to ensure the application is correctly configured to point to the new primary. And you will have to protect the new primary by geo-replicating it to a different Azure DR pair. Second option is to wait for the Azure region to recover. If you've got an application that's sensitive to data loss, and there isn't any logic at the application end to control data loss, then you might opt to wait for the region to recover. However, if the outage is for more than 24 hours and Microsoft finds out that it's going to take a long time to recover the region, Microsoft will force a failover of the primary to the secondary databases. Therefore, if you decide to wait for the region to recover and Microsoft decides to force the failover after 24 hours, you have data loss and the 24 hours of availability loss. So when we're talking about failover here, let's say the East Coast region fails. After the failover in the environment, you can see what's shown there. We've got an online primary. The West Coast will then act as the primary, with the East Coast acting as a new secondary, okay, once that region comes back online. However, we can use a different region other than the East US data center to create a secondary database instead of waiting for the East US data center to come back online. Active geo-replication is now under general release in Azure, and is the geo-replication you're going to be using when you configure your databases going forward. Now, active geo-replication uses always-on technology to asynchronously replicate data to a maximum of 4 readable secondaries in the same or any other Azure region. Active geo-replication is available across all the performance tiers. A typical geo-replication environment is shown in the diagram below, and in this case DB1 is primary site is South Central US with 2 readables at US West and US East. Now the failover process is similar to what we explained under the standard geo-replication slides. With active geo-replication, when you fail over to the secondary database, the endpoint or the connection string is changed, and you'll have to make changes in the application so you can connect to the new primary. Once the failover is complete, all secondary databases automatically point to the new primary. And in addition to manual failover, Active GeoReplication supports automatic failover using something called auto failover groups.